Welcome to our official YouTube channel of Asmi Goswami College of Engineering. I am Gautam Patel from Mathematics Department. Now, my previous all video of the CVPD. Now we discuss new topic: root of complex number. Root of complex number, that means nth root of the any number. We know that complex number is any number, any real integer, yeah, any number is known as a complex number. So we know that when we find the negative root, square root of the -1, then it's not possible. Okay, because it's in calculator it's give much error, but it exists in the complex form. So here we discuss this root, how to find this type of problem. So before goes to the root of complex number, first we discuss our simple requirement, relation between simple argument. Okay, we already discussed in the all previous lecture what is the argument z and means this simple argument z and principal argument of z. Now if we draw unit circle, this one, this is our unit circle, right? So this radius is 1. Now we know that here angle is 0. Now if we rotate, this is 2 pi. Okay, so like this 4 pi, and if we this is right as a plus or minus, this is also plus or minus because it's clockwise, and it's give negative angle, and anti-clockwise give positive angle. So a simple argument z gives multi angle, that means this all r is known as a 0, plus or minus 2 pi, plus or minus 4 pi, and on the positive x-axis this all are like this one, and so on, all are known as a simple argument, because 0 is belongs to set of the simple argument, plus 2 pi, minus 2 pi, all. Okay, difference of the 2 pi belongs in this set of simple argument. But we know that this principal argument has some restriction. It's both are argument, that means it's an angle, but principal argument must be belongs to minus pi to pi. So this is at this point principal argument is 0. Now if we add 2 pi, then we get this 2 pi, minus 2 pi, then we get minus 2 pi. If we add 4 pi, then we get the simple argument. That means by this manner we get this one formula, relation between principal argument and simple argument. Simple argument ARG can be find by using this principal argument z plus here difference is 2 pi, so 2k, that means different integer value, this 2 0 4 minus 2 like this one from this particular example 2, and here pi exists, so this is 2k pi. Fact, k belongs to integer number set z. K is always integer. If we put 0, then both are equal. If we put minus, then this is minus 2 pi. Okay, so similarly we can find any complex number simple argument by using the principal argument. So this is a relation between simple argument and principal argument. Now we use this to find the root of complex number. Okay, so first we evaluate our nth root. Okay, our topic, main topic is root of the complex number. So here we take nth root of complex numbers. Okay, here we use nth root. That means n is any natural number, that means non-negative numbers. Okay, so nth root of the complex number. So we use this to find this formula, nth root of the complex number. So for this, let Z be any complex number Z be any complex number. Now our goal is to find the nth root. So therefore we can write this Z and before this we know that polar form of complex number Z, this is Z equal to R e raised to I phi. Okay, here we use theta as a principal argument, and this phi is simple argument Z. That means we use any angle here. Okay, so Z equal to R e raised to I phi. Okay, now taking nth root, because our requirement is the nth root. So here take nth root. So Z raised to, we can write this is nth root of Z, or Z this equal to same as a Z raised to 1 upon n. Both are equal. Okay, this is 1 upon n, and this equal to, now put here, so in bracket R e raised to I phi, and this raised to 1 upon n. Okay, so this equal to R raised to 1 upon n e raised to I phi by n. Okay, so nth root of Z is this one. Now using this relation, because we take this phi as a simple argument, so this is nothing but this formula. So therefore Z raised to 1 upon n, this equal to R raised to 1 upon n e raised to, but to writing the single line we use exponential. Okay, or no, you use Euler's formula. So Euler's formula, this write as a in bracket cos phi by n plus I sin phi by n. Okay, by the, because of Euler's. Okay, Euler's formula, we can write this. So this equal to R raised to 1 upon n. Now using this relation between simple and principal, we can write this cos, here we use theta as a principal argument, theta plus 2k pi divided by n, okay, plus I sin theta plus 2k pi divided by n. Now this gives, because k belongs to Z, but here we have need n root. Okay, so k is running from 0, 1, 2 and so on up to n minus 1. 0 first root, this second root, third root, and this is nth root. Okay, which is our requirement. So finally, hence nth root of the complex number Z is Z raised to 1 upon n, this equal to R raised to 1 upon n, in bracket cos, we can write this theta by n plus, now here also write here, this is theta is nothing but principal argument Z. Okay, so only requirement is find the principal argument, and by using this formula we can find all argument. theta plus 2k pi by n plus I, okay, I sine theta by n plus 2k pi by n, where k equal to 0, 1, 2 and so on, n minus 1. Now we discuss one simple example, okay, to evaluate root. Okay, so now we take one example, simple example. So example is the fourth root of find fourth root of unity, which is nothing but, this is also right, 1 raised to 1.4. Okay, so now in solution, okay, let now here z is 1, so always let z equal to x plus iy, this is 1, okay, and n is 1 upon n, that means n is 4 here, so n is 4. Now first we find our requirement, this r and theta, that means principal argument z. So now r equal to, we know that this, what is r is x square plus square root of x square plus y square, so equal to x is 1, so 1 is 1 plus 0, this x is 1 and y is 0, because real parties exist, imaginary part is 0, so this is square root of 1 is 1, so r equal to 1. Okay, now theta, that means our principal argument of z, this equal to, okay, now this number is on the positive x-axis, okay, because 1 is on the positive x-axis, so we know that angle is 0, okay, by our previous lecture. Now hence the fourth root of unity, this is, by using this, 1 raised to 1 upon 4, and this is denoted by, okay, this is denoted by, sometime it's ck, so here write directly ck, this ck, this equal to r raised to, because here formula is directly write r raised to 1, r raised to 1 upon 4, so 1 raised to 1 upon 4 in bracket cos theta is 0, so 0 by n is 4, so 0 by 4 is 0, so only remaining 2k pi by 4 plus I sine 2k pi by 4, and now what is k? N is 4, so k is running from 0, 1, 2 and 3, because we have need 4 root, so therefore finally we get ck in simple form, this 1 raised to 1 upon 4 is, now look here, this is also 1 raised to 1 upon 4, but this is different, this is something like this, z raised to 4 equal to 1, okay, and this is only positive value, because radius is give positive, and positive any root is only single value, so this is 1, so this is cancel out, and into this one, so this is only cos 2k pi by 4 plus I sine 2k pi by 4, okay, where k is running from 0, 1, 2, 3. Okay, now we find different k value, and we get all 4 roots. So first we put k equal to 0, okay, So now for k equal to 0, so k equal to 0, this term is 0, cos 0 plus I sin 0, so c0, that implies c0 equal to cos 0 and cos 0 is 1. So this is our first root. Now for k equal to 1, now put here 1, so 2 pi by 4, so cos, that implies c1 is cos 2 pi by 4, okay, 2 cancel, so we get only pi by 2 plus I sin, similarly here same pi by 2. Now we know that cos pi by 2 is 0, sin pi by 2 is 1, so that implies c1 is I only. Okay, so this is our second root. Now for k equal to 2, that implies, now put here k equal to 2, 2 into 2 4, 4 cancel, so we get c2 equal to cos pi plus I sin pi. Now we know that this is 0, cos pi is negative, so c2 is minus 1. And last, final, for k equal to 3, that implies, which is c3 cos. Now 3, so 2 cancel, so we get 3 pi by 2. So this is 3 pi by 2 plus I sin 3 pi by 2. Now we know that this cos 3 pi by 2 is 0, sin 3 pi by 2 is minus 1, so c3 is minus 1 into I, so minus I. So these all are our 4 root. Hence, fourth root of unity are this is plus or minus 1 and plus or minus I. So this type of method to solve any root of any complex number. Okay, so we can use different root for the different complex number. So this is stop here. Thank you for watching our video. Please like it, share it and subscribe it. Thank you.